Hi, welcome. This is Migrating Queries from Lens and Saved Objects, Data Tangles to Data Order. I am Sarah Hudspeth. I'm a solutions architect at Chronosphere on the post-sales side. So me and my colleague Jason, we do a lot of SaaS vendor migrations to Chronosphere, which has a lot of open source telemetry. I'm a really big data nerd. I love books as well, and I'll let Jason introduce himself as well.
Hi, I'm Jason Ng. I'm implementation engineer. I work with Sarah on the post-sales team. She put down that I'm a script guru. I'm not sure I've reached that level quite yet. And I also like to run marathons, so running long distances.
And a quick agenda for today. We're going to tell you why we are talking to you today. We're going to do a bit of an intro. Then we're going to get into all the data tangles that we ran into when we were migrating a customer from Elasticsearch. And just to note that we might use Elasticsearch and Kibana, but it's very applicable to OpenSearch and the visualizations, since OpenSearch is a fork of Elastic, and there's a lot of carryover, but we sometimes just interchange the terms a lot. And then we're going to have a discussion about our approach to untangling it. It's not the only approach. We're going to talk about why we approached it that way. There are probably better ways to approach it, and we're open to feedback. And then we're going to go through some of our successes, and then also some of our failures and our learnings, and then get to a demo, and then leave some time for Q&A. So hopefully you're ready for all that. So basically why we're talking today is, and what we want you to take away from this presentation is we really want you to understand where data is in saved objects and lens objects and how you can extract it. And again, we want to have this discussion about how you approach data webs and when data is unruly, like how do you solve for them? How do you work through some of the disorder and the craziness that happens? And then also we want you to kind of leave feeling like, it's really awesome when you have your data and you can use it how you want to, and it's not stuck in some format, and you can have fun and play with it. And then lastly, we really don't want you to be intimidated by these data schemes. We were very intimidated by them, so hopefully you'll take something from what we learned and start way farther down the road than we did, have fun playing with them. So this is my intro to the talk. I don't know if you all remember one of the first labs in AP Comp Sci. For me, it was Intro to Java 101, but basically you had to program a maze finder, like a pathfinder in a maze, and so you had to get the red dot to the blue dot or the blue dot to the red dot, and you had to write the algorithm or the logic to make that happen for any maze that whatever the lab ran. And if you remember the solution was just always program the dot to take a left-hand turn, right? It's not the most efficient way, right? There's probably a shorter path through the labyrinth or through the maze, but it's thorough and it always gets you out of the maze, right? So this is kind of the metaphor for the approach we took, right? We tried to figure out what's always going to be the left-hand turn. How can we be thorough in our data and make sure we understand what's happening? And it's actually so for us, we work with a lot of different SaaS vendors. We're moving customers from one vendor to the other. Often we're also moving them to open source. And sometimes when we get into their data, we really have no idea what's going on, right? We're in this maze. We don't know what's around the corner, and so we have to have this approach of always touching the left-hand wall, making sure we're being thorough even as we come across unknowns. And so this is kind of what we did with the Elasticsearch/OpenSearch data is we really tried to build from the ground up what was going on with these dashboards and logging queries. And I should say we did have programmatic access to get them all out, and we did try to automate as much, which is, anyway, we're going to get into it. But basically, we didn't know what the data looked like. We were trying to add order to it, and this is our story. Whoops. And let me see if I can. Uh-oh. Here we go. Here we go. Yeah, so to start off this story, I'm actually in the OpenSearch playground right now, and this is a logging dashboard, right? And we kind of had this imperative to get all these log queries out and into the open to redo them. So first step, right, you'd be like, okay, well, let's go take a look at these queries. Well, all right, let's start trying to find where these queries are. First, you would go to inspect. You would get data, right? But then you'd have to go to requests. Requests are looking a little bit better. It looks like we have an index pattern that can be a source, that can be a start of a query. But then when you click into requests, we're like, all right, we're getting some JSON, we have some information, but if you take a deeper look at it, there's a lot going on in here, right? So here we have query and we have bool and we have all these filters and we have matches and we have shoulds and must nots, but at the same time we have all these other fields that we have to be aware of and make sure that we're understanding. Like here's a source, that's probably important. And for this talk, we're talking mostly about how to extract queries, but we also had to extract kind of the data visualization information. So we would, think about getting the aggregations and looking at the histograms and all of this information. Like we all have to grab it and map it. So this looks like a pretty nice JSON, right? So let's take a look at what we would need to do in order to get it access to it programmatically. So you'd have to go to dashboards management. You'd have to go to saved objects. You would have to find the dashboard that you wanted, and then you'd have to export it. And you could include related objects or not related objects, and this is where it became kind of interesting because sometimes you needed those related objects because the dashboard would just reference an object and you didn't know where it was and you had to go find it. So anyway, this is kind of, the start of the journey, trying to figure out, all right, how are we going to move all these queries into a new format? So I like to use Jupyter Notebook for my data analysis prep work. And so I just went ahead and I loaded those new line delimited JSONs that you get from saved objects and tried to start, again, bringing order to it. And here's just a bunch of JSON. I put it in a data frame. Here you can see where we're getting some interesting information about the different types of objects, right? Index pattern, visualization. We have an interesting thing called attributes. I could start pulling dictionary keys that could maybe point back to that JSON that I saw in the dashboard. Anyway, I'm gonna go back to my slideshow presentation. It actually ended up being way more complicated. So there are no official tools if you want to extract data. There is a tool that will take you from Elastic to OpenSearch on the OpenSearch website. But if you just want to find the queries to play with them, for instance, like I went to the PPL session yesterday, so the piped processing language. If you wanted to redo any of your queries into the new pipe processing limit, there's no way just to get the queries, right? You're just going to get another JSON. And as I saw, it looks like there's standard query syntax, but in the next slide, I'll show you actually there's not. The logic in store switches on you all the time. And there's a ton of drift between the Kibana versions of these visualizations and lens and dashboards, and there's not backwards compatibility, so we were really struggling a lot to figure out how we are going to organize everything. And just to note that a lens saved object, OpenSearch kind of uses the visualization, but with Elastic, it's there's a bunch of visualization layers you can add, which adds to the complexity of the nested JSON. And then here are some examples of just kind of the JSON we pulled, right? Title, panel JSON version, grid data, panel index, these look like basic building blocks of dashboards, but they quickly change from one version to the other. So here we have a new type visualization. We have some more attributes down here. Down here, we switch back to lens. It still seems manageable, but then when you get into even later versions, all of a sudden, the places you have to look for the information just gets crazy. And again, not every dashboard uses the same thing. And what we found is within a dashboard, there'll be different versioned lens and saved objects that you have to then figure out, organize and figure out. So that was kind of the setup, and I'm going to pass it off to my colleague Jason, who's going to talk to you about how we figured out how to work with all this data.
Just going to quickly switch to my laptop. And it works. Great. So approach to untangle. So as Sarah alluded to, these new delimited JSONs, they can be intimidatingly complex. However, I really feel like just keeping calm, having a proper and good problem-solving process really helped us, especially with regards to speed. Like when we're doing migrations, it's not in the order of like years or months. It's literally like figure out in weeks. I think our team, along with engineering team, we pretty much figured this out in 1 week.
Yeah.
It was pretty much like a 1 week thing. So having a really strong problem-solving process, understand the problem, first off, it makes things a lot easier later on. And what that meant was, well, a bit of what Sarah was doing, examining the JSON object, but also look at the UI. And I'll delve into this later as well, just to see like what options there are in the UI and how users interact with it, and also using documentation to fill in the gaps. And then listing a lot of the examples, which Sarah also did, like what fields, what values we need to recreate the same data one-to-one for our customers in Chronosphere. And that involved, like for dashboards, like what visualization you want. Is it a time series? Is it a bar stacked? Is it something that maybe we don't support? So for some of the alerts, we weren't able to do, we don't currently support like doing like composite alerts, but we will in the future. And then the query, what filters, aggregation, group by, step size limit we want, and alerts like thresholds and sustain are important data points that we also need. And being able to do these two things then meant that we can then figure out like what data structures we need to manipulate the data to get us to those complete and accurate queries and the algorithm we need for the conversion. And that leads to really what we feel is one of our biggest successes, which is having an automated conversion pipeline to reduce our manual efforts. So as an IE, us IEs, we do a lot of the last mile validation for things that we cannot automate. And so definitely having something that is automated. So once we extract out that data and manipulate exactly how we want, and then that really makes my life and the other IE's life just so much easier. The 80% is really something more that we feel rather than something objective. And we see in our demo like just how quickly we can move hundreds or even like thousands of dashboard and alert assets. And that really means like extracting them from a tenant, parsing them, converting them to Chronosphere spec, uploading them to our tenant, and then we do the final validation. And something to call out is our success in dealing with not only the dashboard JSONs, but also the alert JSONs, like these 5 types: ES query, log document count, metric index, and custom threshold, which we were successfully able to do. And if we were to take a look at metric threshold alerts, like this is like a document that we have for which we kind of go through our understanding the problem process. We define what a metric threshold query is. We go through like the document. We also go through the documentation. We go through how it works in the Kibana UI, and then how to translate that into Chronosphere spec. Where do we find the criteria for the alerts? So it's going to be in this params criteria field, where our aggregations, and then really like a big data challenge that we had was the number of different paths that an alert can take. For instance, one path is like we can have a single criteria for the alert, and it is, in this case, like a custom aggregation type, and that's typically associated with an equation. So for this, we have like a b divided by a plus b, and we need to find out like where are the filters and the aggregations for b and a, and then be able to turn that into this Chronosphere spec, for which we actually substitute those filters and aggregations for that particular equation. But it's not even just this one case. We can have a static aggregation type, so like a count, so a count of log documents. We can have like an average, but we can also have this other path, which is like we can have more than one criteria. We can have 2 criteria, 3 criteria, and each of them can be a custom aggregation type with an equation, or we found that it cannot have an equation. And that was an edge case for which we then saw that, oh, well, it just actually just defaults to a count. So yeah, being able to really understand the problem, leads us to be able to create like a lot of, create that automated tooling, and that's something for which I'm going to get into a very quick demo on. So our tooling in action, be able to turn that messy JSON into our desired output of a very clean logs query in Chronosphere. And yes, this is our migration engine, and we're going to be converting a bunch of dashboard and alert assets. So this is turned off. We're not going to be migrating from a tenant. So yeah, just this one click of a button is going to upload, convert, parse, convert, and upload a whole bunch of assets to our tenant. Oh, this is our test tenant. And so, yeah, we converted and uploaded 11 dashboards here for one of our collections, and 74 out of 75 alerts. So it's definitely not perfect. We missed one there. I think if I check the log somewhere in red, printed to the console. Yeah, for one of our alerts, we ran into an error, which we're going to have to fix before our next Elasticsearch or OpenSearch migration. I think for this one, it's like we have a string and we're trying to use like an operator greater equals n, and the data was extracted correctly, but we need to do a little bit more work to get them to Chronosphere spec. And yeah, really our goal was, printed like some of the queries here, is to just get to this, a very clean logs query from what it was in Elasticsearch. And some of our learnings, migration is definitely a bit of archaeology, a bit of archaeological digging, plus a bit of engineering. Something that we recommend is really to audit objects as early as possible. Don't wait until migration time. So yeah, our team, like they worked pretty much from the very start to be able to audit objects and figure out a migration path for them. And so finding that hidden complexity in the filters and the queries, and then translating that to an automated tool, testing at scale with those hundreds and thousands of assets to be able to get to the bottom of like some of the bugs and edge cases like the one we just saw. And yes, understanding, like we want to be able to understand the data under the hood and to own the queries and not have the vendor schema own us. And why does this matter? Being able to extract out that data, whether it's for our use case, so for us it's like an observability migration use case, and but it could be really for any use case. But having the data be complete so that there's no missing logs, having accurate mappings so that ultimately for our use case, the queries paint the dashboards or the alert visualizations, and they return what the users expect, and establishing trust in those dashboards and alerts. And really, when you start to develop tools like this to be able to convert to different formats, it prevents like lock-in, or something that we even have is like the ability to translate Chronosphere back to something like Grafana. And so, yeah, future-proofing, preventing that lock-in. And yeah, thank you. And if you guys have any questions, we're happy to field them. And
yeah, thanks for listening.
Yeah.
Are you open sourcing your tooling, or
We plan to, yes. As soon as we get through the current migrations we're working on, yes, we want to put it out there so folks can use it and grab the queries however they want to. So that's the plan. It was nice we were at the last session. I was like, oh, great. This is what we need to do.
Part of OpenSearch project, or it's on Chronosphere?
I think we would either do it under OpenSearch or just open source in general. I don't think it'd be necessarily under Chronosphere because it's not necessarily Chronosphere specific. We were migrating them to Chronosphere, but
Because we have already a repository OpenSearch project called like OpenSearch Migrations, where you can replay from Elasticsearch traffic to those. They're also a dashboard migrator tool. It's not as sophisticated as this, but it does the majority.
so yeah, we noticed that, and I guess that's kind of our thing. Like we still needed to get it out of the nested JSON format so that we could play with them and change kind of the query language. Yeah, because I think we needed, well, I would say that KQL for Kibana, yeah, it was very convoluted where you were supposed to figure out the query was so that we could kind of consolidate it. And I'm sure in OpenSearch, as I kind of pointed out, there's sometimes you have to connect all the dots and all the pieces to get kind of a query that's complete. But yeah, no, we hope to add to that tooling. Yeah, no, I think we put it in the file. We hope to just supplement. Yeah.
I know you said about missing testing for missing logs. I was wondering, how did you convince yourself your migrated JSONs or target objects are actually what, I mean, it's represented in the original source, or maybe even how did the users accept that this is what they want? How did you confirm that it is testing? What kind of testing did you do?
Yeah, so our validation process is actually rather manual. So we had like spreadsheets of everybody's alerts and dashboards, and then we had links to the old one and the new one, and a lot of times it was visual validation, like comparing them side by side, and then finding and taking notes on the differences. For the alerts, I think it was the same, and sometimes we also see like there's a time where they're dual firing, and so we confirm that the alert fires and it's kind of replicated across both systems before they cut one over. Yeah, that's another talk. How do you automate the validation process? We would love to know, because that did require a lot of manual validation or manual work in order to confirm it.
Yeah, like a migration challenge is the customer desire to have perfect one-to-one parity and as quickly as possible. Yeah, that is going to demand like at least some level of manual effort for that.
Nowadays with LLMs everywhere, are you thinking of using LLM in some way, shape, or form in your future to make the migrations easier or
Yes. So in our current migration, we did use, I don't know, are we allowed to say what we, anyway, yes, we used some AI to help write the tool versus Jason and I writing the tool. It was mixed. I would say especially since we're open source, so we're Prometheus for metrics, OpenTelemetry for traces, and then FluentBit for logs. PromQL is really, really hard to translate, and we're doing, even from Victoria Metrics, which is kind of like a superset of PromQL, it's really hard to automate that, and we did write a tool that got us like 90% of there, but there's still a lot of manual work with queries because it's a pain of a language. But yes, and I have on my to-do to try to write a script that would actually call the data and try to validate it and see if we could, manually, or not manually, have a tool that crunches the numbers and says, yeah, these are returning data within a certain confidence level of being statistically similar. But yeah, what's next? Another talk. Yeah, thank you.
Thank you.
Awesome. Oh yeah, and here is the Elasticsearch to OpenSearch. So if you guys want to go look at that tool, there's that.